Okay, is my screen visible? Can
Yeah.
Yes, Partha.
okay, thank you. Um, One sec, let me get organized a little here and uh, not this one. Okay. What? Sorry about that. We were covering some things last week. We started with 1960s monolithic computing using mainframes, and then we went to how IBM introduced time sharing, TSO, the time sharing option, and then PCs come into play. So local data storage and local processing was enabled by that. And then we had object-oriented language and object-oriented design coming into play, the model view architecture, the J2E container services, and then some design patterns we looked at, one the visitor design pattern, and then we talked about server virtualization. And the slide that is on the screen is the server virtualization part of it. We went through all these VMware was introduced in 1998. This was the first time you could have one piece of hardware system which could host more than one multiple virtual machines on itself. Um, there were two versions of this so-called hypervisor that was introduced, the type 2 hypervisor that requires another operating system to sit on. And Jesus X Server was VMware's name for it. And the other one was the type 1 hypervisor, which would sit on the bare iron. That is, you would just take a compute system without any operating system on it and then install the ASX server on it, and that becomes a hypervisor, which will you can create and run multiple VMs. It was not limited to just Linux. You could run Windows, you could run Linux, you could run yeah, pretty much these two operating systems and variants of Linux also, of course. And then VMware has, of course, grown quite a lot now. You got a lot of, so it is actually the leader in the server virtualization. Apart from that, we also had things like in networking side, a lot of enhancements and improvements had happened. One of the mainly network connectivity became faster because many of the communication companies started putting in fiber. And firstly, they started allowing, started leveraging the need for connectivity and started giving internet connectivity through modems, then fiber, and then finally it ended up with a lot of network virtualization. So what is called software-defined networks, where you don't have really to have a hardware device to provide networking features like routing. Um, so the physical network is only needed for packet forwarding. Just like voice communication, you need some packet forwarding like that. And everything else that requires to be done in all the other 7 layers or the five layers. The top 5 layers of the networking stack can be done in software. The other major thing that came in was containerization. So when a user is running a process or an application on an operating system, there could be many instances when the application could modify the underlying operating system We see that even today in many applications that if you want to install something on, let's say, Windows, and you want it to run you have to probably put some entries in the Windows registry. You may need to modify an environment variable so that the path to the executable is available. Same thing with Linux. If you want to set up a service on Linux, then you may have to add it to the service controller and the system control and add it so that it's available anytime. So the need was felt for clearly isolating an application completely from the operating system so that it runs in its own space and does not touch the operating system that it relies upon. And when the application is shut down, it has not modified anything in the underlying operating system and can be deleted completely without any impact on the system that it was running upon. So the first thing that came was Google's process containers in 2006. And it limited the resource usage of CPU, memory, disk, I/O of a collection of processes. Later on, this was named as C groups, and C groups is what we know today in what is called the Docker containerization. So Linux kernel, um, with the Linux kernel 2.6.24, this became merged with the Linux kernel. You don't have to add C groups as a separate package into any Linux. And then in 2008, we had the Linux container or LXC. Even today, Docker in the underlying architecture of Docker, you do have LXC as the container. The same goes for container D, another containerization. And so 2013, when Docker came in, and then Docker's investment in containerization has been tremendous. They have a huge ecosystem of images, Docker images that anybody can pull and run. So if you today you want to run, let's say, a SQL server as a well, not SQL server, but MySQL or PostgreSQL or MongoDB as a container, you just need to pull it down from the public Docker hub and run it on your Docker server. So, in the late 1960s, one of the people who were in the forefront of computing and computing virtualization, he predicted that computation may someday be organized as a public utility. So just as we get our water supply and our electricity supply as utilities, and even some gas is sometimes a utility in many places, it's piped in. So we could pipe in compute power as we pipe in water and electricity and gas. So virtualization and then metering, that is how much of the resource as a utility are you using, what is the pricing, what is the service levels, in the sense that will it ever get cut off, will the utility that I'm using ever get cut off, ever get damaged and not available. How do you allocate resources if you have a pipe into the utility? How do I regulate who uses how much within my organization? All these things, you know, they impact how quickly IT as a utility actually takes shape and starts getting used. Apart from this, a provider of this utility has to address other concerns. No, just providing compute power as a utility is not enough. Such a provider has to worry about, if I want to displace the data center and people owning compute systems and use my compute utility, uh, I have to address some things that the corporate data center addresses, some of the concerns. First, standardization, of course. If I stand up one Unix machine, let's say I want a Ubuntu 18 or a Red Hat 7, the next machine I stand up must be exactly similar to that in all the way that I have configured it, and all the way that my organization wants a Linux, a Red Hat server to be, for security hardening, pre-set of users and user permissions. All that should be standardized. And the corporation is always worried about high availability. What do you, the utility provider has to provide the high availability that the corporation needs. Business continuity. This is another, there are two things that an organization is always worried about. If compute resources fail, how are we going to continue our business? So there are two things in this. There are one of the things is disaster recovery, the other is business continuity. Both of these are sort of intersecting concerns, and the utility provider has to provide facilities to address this issue. And of course, security, privacy, and other concerns are always there in any organization. And the other thing that a utility has to worry about is bandwidth. How do we assure that network bandwidth is sufficient to service the organization and its customers? So, any compute as utility has to have satisfy these five things. On-demand self-service, of course. So you should not need an administrator sitting somewhere else to give you support for this. You should be able to do it yourself. Then you should have a ubiquitous network access. So my employee sitting at home or working at some other customer site across the world should have access to the compute resources that are being provided. And it should be through standard internet-enabled devices, not through some special connection that is required. And you should have location-independent resource pooling, in the sense that if one location of the utility is overextended, then there must exist another location from which I can pull resources and pool these resources together to continue my organization's work. And you need rapid elasticity, in the sense that if I need more resources, I should be able to provision them quickly. So the resource availability should be elastic, both in growing it as needed and scaling it down when the demand goes down. And then you must have measurement and pay-per-use, right? So there must be metering in the sense that the organization, whatever utility power or compute power an organization uses, must be metered. And at the end of the day, you must have very clear-cut pricing policies, and you must only charge the organization as much as they have used, and not some lump sum cost. So these are the five things that any compute as utility provider must provide. So from this point onwards, compute as utility we will start calling as a cloud. And a cloud has four deployment models. The first is a private cloud. So you provide an infrastructure, but this whole cloud infrastructure is only meant for the use of one organization. So you have only a single tenant, and the single tenant uses all the resources that are available within the cloud. You run the cloud for the organization, but you will I mean, the charges the metering part of it doesn't work here. You have to charge everything that you're incurring as costs to the organization. Then you have a community cloud. It is shared by several organizations, supports a specific community that has shared concerns. Right. So you could have a group of companies that contribute to something that is common to them. Many of these foundations, the Cloud Computing Foundation or the Linux Foundation, they do run websites, and this is commonly shared by several organizations. These are just examples of websites, not clouds, but the concept is similar. Then you have a public cloud. This is what we know of most commonly today. Things like Amazon Web Services and Google Cloud. They are all public clouds. They are available to anybody, uh, and anybody can buy services from any one of these cloud services. And the fourth model is a hybrid cloud, where the cloud infrastructure is composition of two or more clouds. You could have private and public together, or community and public together, and they typically, what today's hybrid clouds look like is an organization have what is called an on-prem cloud or an on-premise uh, cloud presence. Um, like even AWS provides some of these now today. You could set it up in your own data center, and then you have public presence also for the organization, and the connections exist between the on-prem cloud and the public cloud through some sort of VPC virtual private network channel, and that is hybrid cloud as we know of today, the most common hybrid cloud. There are also three service models. The National Institute of Standards and Technology, NIST, has published these. So the first is infrastructure as a service. This is just pure virtualization in the sense that whatever infrastructure you're running in your data center, like Windows systems, Linux systems, Solaris systems, whatever, will be provided for you as virtual machines in the cloud. So that's infrastructure as a service. Second is software as a service. So I'm running a web server locally. If I want a web server to be on my remote cloud, if a provider is able to provide web server services, then that's software as a service. Same thing for database. Database as a service is a software as a service.
So can we say like the Salesforce is a software as a service as an example, right? So
Yes.
anything that we subscribe to some of the products like Uber, maybe it's a software as a service, right? Because it's are these good examples, Partha?
These are all examples of software as a service. Some of these are actually cloud hosted software as a service. There is a distinction between the platform, the cloud provider providing some services, and a third party providing services that are accessible through the cloud. So Salesforce is one such thing. Similarly, Office 365 is software as a service, but it is not provided by the cloud provider, but by another organization which hosts it on a cloud. Typical software as a service would be database as a service.
Okay, got it.
Okay, that is provided by the platform. So AWS has database as a service, Azure has database as a service. Similarly, Google has database as a service. So that is software as a service provided by the platform provider, by the cloud provider. And the third form of service is platform as a service, which is you could have a Docker orchestration platform like Kubernetes available as a platform as a service. OpenShift is another platform as a service. It's another Docker orchestration. So these are some of the these are the three models that have been defined.
But Partha, just there was a question also. I'm coordinating the questions, right? So Ashwin has asked some examples on infrastructure as a service and platform as a service. For the software as a service, you gave a good example like database and so on. Platform as a service, you gave example like Kubernetes platform, Docker platform, or even like nowadays Microsoft provides Microsoft Azure platform, right, where you can Microsoft IoT platform where you can build IoT products, and blockchain platform. All those things are the platform as a service. Okay. Infrastructure as a service is what the people just give VMs. That's all, like a computer, software computer.
Just VMs. That's correct.
So now if I go to the Amazon, I can reserve a VM and then I can install my website or whatever. So that's taking the service, paying for the VM every month is an infrastructure as a service example.
Correct.
Okay.
That's correct.
Ashwin, did that answer all your questions? I guess it's pretty clear.
Okay, I'll take that as it answered.
Okay.
So infrastructure as a service is the most basic cloud service model. It provides virtual machines, memory, storage, network components, and other infrastructural resources, and they should be accessible through internet, through a virtual private network. So it's not just virtual machines, because virtual machine by itself, it definitely requires memory. So you should be able to ask for and get as much memory as the particular virtual system requires. The virtual system also requires storage. You should be able to obtain the amount of storage that you require for the system. You should be able to obtain all the network components, like you want a private network, you want a public network, and you want connectivity to a specific VPN service or a specific external service. These things must be made available. That's also part of IaaS. So the cloud provider would provide virtual machines. They have to provide some form of secure access through a VPC or a VPN. They have to provide some sort of storage, because virtual machine requires storage, and they should provide networking. So these are the components that would be required as a minimal for infrastructure as a service. And if you're having more than one virtual machine doing, you need some sort of load balancing and routing, and networking comes. Routing comes into networking, but you also need load balancing services. So some of the things that the cloud provider of IaaS must provide is some sort of self-service, where you get a way of the end user directly going and provisioning whatever VMs are required with all these storage, memory, networking that is required. And you also must have a scale out, scale down, automated as far as possible. And then you must have metered pay for what you use. That will be the key characteristics of infrastructure as service. Now we have, so cloud providers do give you software provided services. So very commonly, monitoring and logging are two such common services that are provided by cloud providers. So there are some examples there: Azure Monitor, AWS has CloudWatch, and then you also have things like IAM and Azure Directory Service for tenant administration. Then AI and machine learning. Kadir just mentioned IoT as a service. So AI, machine learning, data warehouse, RDBMS, database as a service. These are also other examples. Okay. So apart from just the infrastructure as a service, could provide software as a service offerings. So which would be monitoring, performance monitoring, high availability monitoring, and so on. And again, we just talked about this in the last slide with the question on software as a service. Third-party vendors might host their cloud-based applications like Salesforce or whatever PagerDuty, and so many other services can be hosted as software as a service on a cloud, but these are not directly provided by the cloud provider. So an example is Office 365. It's a cloud-based service, but not an Azure software as a service. Okay. Then we have platform as a service. Platform services are Kubernetes, of course. All cloud providers have this. AKS, Azure Kubernetes Service. EKS is Amazon's Elastic Kubernetes Service. OKE is Oracle Kubernetes Engine. IK is IBM Kubernetes Service, and so on. Docker container services are available. Though I have mentioned here that they collapse into Kubernetes, it's not really so. You can go to Mirantis and just get a Docker orchestration without any Kubernetes, or you can get it with Kubernetes. An important Kubernetes has deprecated Docker as their container platform. They are
Is it on my side, or can you all hear Partha well?
No, no. The problem is from my side.
Yeah. We kind of lost you for last 2 to 3 minutes, Partha.
Okay, I'll go through this slide again. Now everybody can hear me?
Yes.
Yeah. Last a minute, right?
Okay.
Not. I think the last one that we heard from you was the first point. I think after that it started kind of, yeah. Go ahead.
Yeah. So platform as a service. So the vendors also offer platform services, and the most talked about is of course Kubernetes. So the acronyms here, AKS is for Azure Kubernetes Service, EKS is Elastic Kubernetes Service from Amazon, OKE is Oracle Kubernetes Engine from Oracle Cloud, IKS is IBM's Kubernetes Service from IBM Cloud. Docker container services, I've written here that it collapses into Kubernetes. Not really fully true. You can get Docker orchestration services like Mirantis provides Docker orchestration services, which are both Kubernetes based and non-Kubernetes based too. You can have Docker Swarm running on Kubernetes on Mirantis cloud without having to use Kubernetes. Java as a service is also an emerging platform as a service. Some of it was attempted before, it never matured, but it is happening in course of time. It will happen. So apart from software as a service offerings, you also have platforms. Kubernetes is an example. Java as a platform is coming. Docker Swarm is already available, and so on. What I mentioned was that Shravan made me aware yesterday that Kubernetes now has deprecated Docker as a containerization engine. They want us to use Containerd. It's another containerization engine. Actually, underlying Docker is Containerd. So the transition should be very straightforward and simple. So at the end of the day, this is the total cloud that we are looking at. Any cloud that we look at today will have all these components. So you have some sort of secure access there. You will have some sort of key store where your secrets can be stored. You have virtual machines. You have storage here. You have networking here. And you have some sort of load balancing services. You have identity and authorization, identity and access management, IAM services. You would have container services. And you could have things like an IoT hub, database as a service, software as a service offerings, and some automation to run your pipelines in, You would have monitoring available as a service so that you can take your application services and tie them or link them into the monitoring and get monitoring out of it. Functions as a service, you can run functions as a service without needing any database backend or even standing up any VMs. Things like API gateway and service mesh we'll talk about in the next session. Function as a service, infrastructure as a service, platform as a service, software as a service, database as a service. These are all offerings that come from various cloud vendors. Probably all the cloud vendors have them. So this is the cloud that we have in 2021. How it's going to evolve. It is going to evolve. We are going to have more and more innovation going on in the cloud. So I've come to the end of this first presentation on cloud, and so we'll answer any questions, and we'll go into the
second session, right, Partha? Yeah. So
yeah.
let's take
Before that,
let's take a few questions here. So there's a couple of things that I wanted to personally also ask. There are function as a service. I understand now. What cloud providers are doing is they are trying to abstract as much as possible, so we don't have to really worry about what is below abstraction, right? So the abstraction happens in multiple levels, as you rightly put, right? Infrastructure level abstraction, service level abstract, platform level abstraction, service level abstraction, function level abstraction, and all those kind of things. Right. I heard, and good that you mentioned service mesh, which you're going to talk about it in future, so I won't ask any questions on that. But there's one thing that I see here, which is not there, is something called, as I keep hearing, serverless. So could you share your insights on that? What is it?
Yeah. Serverless is again very, very similar to function as a service. Okay, let me ask Vikas to talk about this. Vikas?
Yes, Partha. Hi, Partha. Hi, everyone.
Yeah, the question is, what is serverless?
Yeah, so serverless is a recent technology in that, like, we are just using the computing power from the cloud provider, and we don't actually using the underlying infrastructure. So
Okay.
suppose if you wanna run like a MySQL database, or you can say if you wanna run any function on your website, then you might need a underlying server to run that function. But in serverless architecture, how it works is like cloud provider offer you services like AWS Lambda or GCP App Engine or Azure Functions. So in that, you just need to write your logic. So if you want to store something from website to database, you just need to write that Node.js code or Python code in the service, and then you need to apply that API logic into your front end, and it it will do work for you. You don't need underlying infrastructure to run that service. We will talk about it more in probably next session, or if we have time in this session, then I can just walk you through that thing.
Yeah. So I'll leave it to you both. You're supporting Partha to help on this. I'll leave it to you both. But I think I understood the crux of it, right? So if I wanted to host my website, I have to go and get the VMs and then configure networking, everything manually I need to do. But when it comes to the serverless, I don't have to really worry about servers. I just have to say I have to deploy, and rest everything the cloud providers takes care of it. It's pretty clear conceptual wise, I understand. The details are many. And for the details to learn, obviously, we have future sessions, in this particular topic. And also we have 3 more sessions in the Eventbrite where people will learn the details. And this session is intended to only understand the basics. Thanks a lot, Vikas and Partha. Hey, I just wanted to do some little bit of governance, team. If you can really help me with this, can you, first of all, you all know the Testoper, right? Testoper is all about It's a non-profit community, and it's a people-led grassroots movement. So you all can really contribute. In fact, Partha is taking this session today, and you have some additional sessions that you want to take. You can look up in the Eventbrite if something is interesting that you wanted to contribute or jointly contribute. Please reach out to me. On the logistics side, I have a few things, and then Sean, I will answer your question. So first thing, I kindly I have a request for you all is, you saw in the email, you saw already our team has posted it. There are certain new people who have joined, I think. So I'm just sharing my screen. If you go up here, see it is posted by Nahendra here. Please look at this one. For those who are new and who do not have access to the Microsoft Teams, first join our WhatsApp link group. It's only for the closed group who joins our program, and provide your details, first name, last name, and email address. We will add you into the Microsoft Teams. And once we add you into the Microsoft Teams, then you will be able to see all the things that I am showing you in the screen, the Testoper community projects, all the activities that we do. You see here a lot of people collaborate before and after the event. You will also be able to do that. That's the first one that I wanted to say. And the second one that I wanted to say is there is number of events that we have. You can go to this link here in the Eventbrite, and please register for the events, and make sure if you are attending this event, we have 4 more sessions which is going to be provided by Partha. You also go and register for all the 4 sessions to attend Partha's session, right? And he has 4 more sessions. That's the second key governance I wanted to say. And the third most important thing is team. Please, I'm going to give you 1 minute, okay? I wanted to give you 1 minute, and I also wanted to introduce you that we have coming up on March 20th, a meetup program where we have great speakers like VP of Tech Mahindra and PwC from IBM, head of AI Edge IBM. So there's number of people, and CEO of WaveLab. So there's number of good senior executives are going to come and share at a very high level how AI is impacting the connected industries and automation. It is a wonderful program that we are trying to put together, and it was spearheaded by 7 or 8 volunteers of Testoper who came up with this plan to organize this particular program. And I wanted you all to kindly take 1 minute, couple of minutes, go to this link that I have typed you in this chat window, and register for me, please. Okay. Please take while you are listening to Partha's session or whatever, please go to this link and register yourself. And the last thing that I wanted to talk to you all about is, you may not know that we have number of videos uploaded in our YouTube, and we do number of program announcement, number of good things that we do in various different social media. And I'm pretty confident you know them. You have joined them, and if you have not joined it, I also kindly request you to really go to all these links whichever the social media that you are in, and please register and join us and follow us. So take a minute to copy these things, right? Please, you all take a minute to just copy all the things that I typed here in the chat, put it in the notepad, and immediately or during the session and immediately after this session, do me a favor of going and following us in all the social media, and also register for this meetup that I was talking about. Like I said again, right? Testoper is a people-led grassroots movement. We need help from each one of you to come and present in our next sessions. Spread this to your friends, colleagues, and ask them to come and benefit from all the good things that we are doing. That brings to an end of the governance minutes that I have to take away from Partha. Partha, over to you. The floor, please continue with your second topic. You have another 20 minutes that you can spend, please.
Okay, thank you.
While you are opening up Partha, there are a couple of questions asked by a few gentlemen.
Yeah.
Sean asked the question, from security threats incident perspective, cloud is safe or local IT setup is safe? This is, yeah, the question always comes up. Any comments, Partha, for that question?
Neither is, I mean, there is nothing that is completely safe. Okay, you have to accept the fact that there's nothing that is completely safe. Whether the cloud provides equal or better security than your local data center and local security, they provide equal security. In some cases, the cloud provides even better security than you can provide yourself, because the combined knowledge and experience of many cloud users and cloud organizations that use the cloud has gone into the security setup of many of the clouds. They have been at it for many years now, and they have gathered experience from many different applications, what sort of security threats are being faced. So they have I mean, each cloud provider has a very dedicated team just directed towards security. And so the VPC that they provide and the other monitorings that they provide, security and other monitoring that they provide, is a combined knowledge base of multiple years and multiple organizations and multiple applications. So you actually are getting better security if you're using a cloud. So I hope that answers the question. So and I also hope that people are able to see the screen. So we'll get into our next presentation immediately. This is what we have as the cloud today. So, so if somebody says, let's adopt cloud computing, what does that actually mean, right? And what are all the things that I need to go to cloud, to go cloud? So, thinking about it, these are some of the things you can actually benefit from going to cloud computing if your applications are composed as a set of microservices. Very, what shall I say, high level statement. We'll have to have a look at what is microservices. What do we mean by microservices? We know services, at least some concept of services. Like you can have a credit rating service, you can have a ancestry tracing service. But what are these microservices we are talking about, right? And then the second thing you must have if you want to go to, if you can benefit if you go to the cloud, if you have short release cycles that are rapid, painless to code, build, test, and deploy. So if you have even a 1 month release cycle or a 3 month release cycle for a piece of software, I mean, release 1 is come out today, release 2 is going to come out in April or May, that is not rapid. And that is one thing. The other thing is it should also be painless to code, build, test, and deploy. Well, painless is a very, I mean, not achievable, but at least as pain-free as possible, right? And the environments you should be able to tear up quickly and tear down quickly. So you should not be spending the 2 weeks in standing up a Linux system with all the hardening that it needs and all the extra software that you need to put on it for your application to actually be deployed onto it. So you should be able to rapidly bring up a system, a test system, do your tests on it rapidly, tear it down rapidly, so that your costs are minimal. Okay. So if you have all those things, you can go to microservices. So Martin Fowler, the one of the leading lights in anything to do with programming, object-oriented programming, and microservices, and so on, he has written actually a set of guidelines for what you should be. I mean, if you want to go to microservices, what you should already have in place. So first thing is you must have rapid provisioning. We saw that it's, you should be able to quickly stand up a system and quickly tear it down. So you must have rapid provisioning. Already you must have basic monitoring in your systems. The monitoring of a system is not an add-on. It is to be built in right from the day you start coding. So the monitoring construction is already be there. You must know what you're going to use for monitoring, and you must already put in the code as you start building the code. You must have some system of, I mean, this is not even going to the cloud. We are speaking of an in-house IT development work. You must have very, very rapid application deployment. When did Microsoft introduce daily builds? Daily builds were introduced probably some 15 years back. So at the end of every day, the Microsoft Word application or the Microsoft Excel application or the Microsoft PowerPoint application must be deployed in the system, ready for being tested through the night, and then next day morning, all the defects must be, listed, and people should start working on the defects. So that was some 15 years back. And daily build is no longer considered rapid. At least 3 to 10 builds a day is what is considered rapid. Even that is, 10 at a minimum is considered rapid. So to achieve this, the rapid provisioning, basic monitoring, rapid application deployment, it actually is, there is an organizational shift that needs to happen. You must have a very close collaboration between development and operations. And that has been termed the DevOps culture. So it's not that development is a separate team and operations is a separate team. There must be a very close interlinking between these two major teams. Continuous delivery must be fully embraced by everybody in the team, in the sense that every one of us will contribute to continuous delivery. So what does that mean? The development team must do frequent check-ins. As soon as they are ready with unit testing a feature or even a portion of a feature, check it in. So any organization that is adopted DevOps culture, the regular check-ins is an order of the day, in the sense that within a day, each developer would probably check in at least 20 to 30 times, because that's what is gives you continuous delivery. And you must shift to what is called product-centered teams. Uh, I just have a little to say about the product-centered teams. Typically what teams have been is you have a development team, and then you have a test team, and then you have a deployment team, and then you have a production team. And each team thinks of its responsibilities as just that. I need to develop, I need to test, I need to package, and then I need to deploy, and then I need to operate. This is, function centered team. Development function, testing function, package function, deploy function, operation function. What this speaks of in the product centered team is the product, everybody must own the product. Whether you're a developer or a tester or a packager or a deployer or the operator actually running the production system, all of you are one team. Every one of you is responsible for the end product getting out on time, getting out with all the quality, inbuilt quality there without bugs, and running without failing or without uh, falling over. So every one of you is responsible for it. That is what is called a product-centered team. So today's teams, there is agile and DevOps aware teams. You don't have a separation between DevOps and development and testing and packaging and operations. They are all one team. The team consists of developers, testers, DevOps. At least one DevOps person is embedded in the team, and then the packaging people are also in there, and the operations team is also present there. So every one of the team forms the whole team. That is the product-centered team, and the success of the product is what everybody is concerned about, not the success of their function. And if you look at Martin's paper here, there's also a maturity model that he has. Just as we had CMM type of maturity models, you have also a DevOps maturity model. Now we come to microservices. Conceptually, microservices are very easy to understand. They are just an extension of the MVC architecture, or it kind of went from a monolithic to client server and then to the MVC architecture. And so you have a monolith. It breaks down into model, view, controller components, and then it is very conceptually very easy to see that, okay, you can even break this down further into microservices. In practice, it is very difficult. It is tough. It definitely represents a culture shift. Part of it is what we saw in the last slide, but it also, just as we have books like Thinking in Java and Thinking in Python, even from the beginning, you should start thinking in microservices. So let us see some of the things that we need for this. Over the years, people who have worked with microservices or the microservices type of application development, they have learned some lessons, right? Many of the projects, existing apps have been converted to microservices, new apps have been developed, and what they have captured their learnings are as what are called patterns. So you have decomposition patterns, and so decompose by business capability, decompose by subdomain, use a strangler pattern for refactoring existing apps, a very, very evocative name for a pattern, strangler pattern. And then you have integration patterns. You have the API gateway pattern, the aggregator pattern, the client-side composite UI pattern. This is an interesting one. We should actually use it. A UI is not just composed of just the screen alone. So UI is divided into regions. So typically, if you look at any UI to you have a banner region which is on the top, you have a navigation region which is on the left, and then you have a content region which is sort of in the middle. So these three are completely served up by three different components. Each one of them is a separate microservice, and they work together. And why this is so is because the banner does not need to change as often as the navigation panel, and the navigation panel does not have to change as much and as often as the middle section, which actually delivers the content. So if in the navigation section you click on resources or VMs, the list of VMs is brought up in the center, in the content pane or the content region. So the amount of change that needs to take place in the navigation panel is very little. So that is why it is a separate component which does very little work. And so the application is served up much faster if you do it this way. So that is what is this client-side composite UI pattern. You compose the UI of different regions which are served up by different microservices. You have observability patterns. That is, the log aggregation is one such pattern. So all the logs are collected together and visualized together, and then you can navigate between the logs, between components, between functions, and so on. You have performance metrics, the push model or the pull model. So most of the monitoring services that clouds provide are the pull model. You basically instrument your application with the code that is required to work together with the monitoring service provided, and the monitoring service will then pull the data on monitoring from your microservice and publish it to a central site. Uh, Distributed tracing. This is again a very interesting pattern to think about. If you have multiple microservices that provide the output for a simple request from the client, So the request is going to be going to the first microservice that it is directed to. Then the first microservice is going to call a second and a third. The third one will call a fifth. And then the whole aggregated output of all these microservices together goes to service the client's request. How, if something breaks in between, how do you trace it? Which microservices is broken down, or which part of this whole chain has broken down? So you must have some sort of tracing, and the tracing should not be so onerous that it clogs up the works and slows down your application completely. Health check. You must have some sort of health check that says which of the services are continuing to run, which are being overloaded, and so on. So services can die just because they are getting overloaded. The service will stop responding if the load on it is more than what it can carry. So there's a health check required. That the health check would automatically should kick off some scaling, horizontal or vertical, or whichever way you designed it, and so on. This is another interesting concept, cross-cutting concerns pattern. We look at it in more detail. So one of the concepts is whatever environment parameters are there, completely externalize it. An example: if you have an application and you have integration test, user acceptance test, and then deploy into production. So you have three different environments. The three different environments will have different configurations, because what is the configuration of the test environment is completely different than what is required for the user acceptance test environment is different than what is required for the pre-deploy or the deploy environment. So you have to externalize these environment parameters, and that is this. So it is something that is across. So as soon as the deployment says I want to deploy this application now in the test environment, then the test environment parameters must be picked up, and the automated deploy should stand up that environment and deploy to that environment. Okay. Service discovery, we'll discuss this also in more detail. Circuit circuit breaker pattern. Okay, these are all, at least for awareness sake, you should be aware that these things exist so that you can. Then blue-green deployment pattern is another one. You have to understand what is blue-green. Green is the one that is the production environment. Blue is the one that you're testing. As soon as the blue testing is done and you're ready, you will switch. You switch the green environment to the blue environment. So basically, you take all the connections that are going to the green and then reconfigure them to go to the blue. And then the blue becomes the green environment. There are a set of database patterns also. They're not covered here, but one of the most famous of them, or most well-known of them, is called the CQRS pattern. Command Query Responsibility Separation. That's what CQRS stands for. So of the database CRUD matrix, the except for the read, everything else is a separate concern. The read does not require transaction, and does not require acid tests to run on the transaction, and so on. So the command and the query part of it are separated out. So command query responsibility separation, that's what the CQRS database pattern. So you get faster response on queries, which is what most of the requests from clients are queries. Actual transaction that changes the database records are much less, and they can be separated out so that they can be dealt separately. How do you, what is one of the primary requirements for breaking down into microservices? You must know the business domain of the application that you're writing quite well. So what happens in real life is, if you're a consultant who's going in and trying to help, you're a cloud consultant and going in and trying to help an organization move into microservices, you have to talk to the domain expert there. They know their domain much better than any than you are just coming in there. So if you are becoming a DevOps consultant or a DevOps, you're becoming a microservice cloud computing professional consultant, then you must understand that the domain knowledge lies with the business people who have been working with that business for many years. So you have to talk to the internal people to get the domain knowledge before you can even attempt to break it down into microservices. These are some old reference architectures that were published by NIST. They are no longer really very common. I'm just going to go through them fast. And there are some, even today, there are, this is from Azure. Azure has got a number of cloud design patterns. Anti-corruption layer is a good one. Um, uh, Bulkhead is a good one. Circuit breaker, again, we just looked at command and query responsibility separation. That's another one. So these are, again, things to be aware of when you're looking at microservices and cloud computing. AWS also has a set of patterns that they have put together. So, and under different categories. Okay, now we get into actual, we are at the end of our time today at 11.
Yeah, that's correct, Partha. There is a question from Shravan. Uh, Shravan, do you want to ask the question?
Yeah, yes. So there are two questions actually. So you said one microservice can invoke another microservice. So I was wondering, is there a defined interfaces which have to be used for this intercommunication between microservices? That's the first question. And the second question is how so if the health check has to be ensured, do you have to make sure that all the microservices are in a healthy situation or not? Is that the way it goes on?
Okay. To the first question, to answer the first question, we have to look at what is called the service mesh. Service mesh is a mechanism by which every microservice registers itself into a service registry. Now think of it like this. If you have multiple microservices, how does one microservice know how to find the other microservice? Right. If a set of microservices are working together to provide an end result to the end user, how does one microservice know how to reach the other microservice? Because whenever you deploy a microservice, it acquires a new IP address. Can you hard code every IP address into every microservice? What happens when you deploy a new version of one particular microservice? All the others are still the same. So you have to kill the old one and then stand up the new one in some fashion, either blue-green pattern or the rolling upgrade pattern, but only for that microservice. Then the IP address changes. How does the other microservice know where to get to this microservice? So you need what is called a service registry, where every microservice registers itself as soon as it is up and running and healthy, and registers itself saying, this is the microservice I'm providing, this is the service I'm providing, and this is my location or IP address or how you reach me. The second part of it is when we are going to look at it in further slides. Your question is a little answered much further down. The the communication between microservices is so very frequent and so very so much networks that you need what is called a service mesh, and you need the service mesh is what actually does this. The service mesh has just two components. One is the service registry itself, and the other part of it is what is called sidecar. We just heard the term sidecar in the previous slide. And this is also separation of cross-cutting concerns. So instead of saddling your main microservice code with the constructs and request response code that is required to communicate with another microservice, you pull it out into what is called sidecar. So the sidecar is part of the service mesh. The sidecar is the one that has the code that queries the service registry, gets the for the service name that it is looking for, gets the IP address, and then does the communication with the IP address, gets the response from the other microservice, and passes it back to the main car or main microservice. So maybe I should just go down to that particular
Yeah, so
slide.
I think we can cover that, but let me ask one question on that context. See, Partha, there is two aspects to it, right? One is from the infrastructure point of view, IP connectivity and all those kind of things. The next one is the functional point of view. Each microservice, let's say a microservice is designed for a financial transaction query, right? How much money you have, how much money is left, something like that, okay?
Right.
Then that's a functional API, right? So the functional API communication happens between microservice A and B. And then the second one is the infrastructure level communication happens to make sure you are alive, you have enough resources and things like that. So the question I had was both the functional and the infrastructure, everything is being done through sidecar, or is it just only infrastructure? That's my question.
Anything that is not business logic concerned is done by the sidecar.
Okay, so then it's infrastructure. Okay, got it.
Okay, so
Okay.
anything that is business logic is done by the microservice itself. Anything that is related to infrastructure, like communication between microservices, discovery of microservices, logging, transaction logging, audit logging,
Got it.
all that will be done by sidecar proxy.
Got it.
So
Perfect.
this diagram that is now on the screen actually is a very high level view of what is a service mesh and
And
how
how many slides? This 24 is far from the last slide that you presented.
last slide was much earlier. Last slide was we were somewhere.
Yeah, okay. So you know what? Let's start asking any questions here. So because you will cut the flow. So we will leave you to go through the flow. You're actually doing a wonderful job to helping us to understand from all the way from 80s to what cloud computing 2021 was. It was an amazing session, and now today you started with explaining us one step at a time into this microservices. So we will not go into the future question. Stop asking it. We'll let you to go through the flow, Partha. Okay, in our next session.
Yeah, today's
If you're
time is
okay with
over.
it, yeah, if you're okay with it, allow me to say a couple of words and close the session. Or do you have something else to say?
No, nothing else. Just join the other session if you want to learn a little more about service mesh and API gateways.
Yeah, I'm very excited. This is like a fundamental thing. There are so many sessions and courses that are out there which talks jump directly into something without knowing the foundation of it. And you are really helping us. You are doing a great justice and a wonderful job to fulfill the topic called cloud fundamentals, which is the session topic today, right? You're doing a wonderful work. I know that we have 4 more sessions from you. We're looking forward to that, all 4 more sessions. Plus, we are also very excited to join your study group that you are organizing every Tuesday. Guys, if those who do not know, go to the Eventbrite and register for the study group. What happens in the study group is Partha is teaching here in Codeathon, the presentation. In study group, he's available basically for you guys to ask any number of questions to him. Maybe do a joint coding, joint, Microsoft Azure. He has some accounts, so he can show you guys. So, if you want to really make friends and informal way wanted to learn things together, you can do that in the study group. Partha will always be there. And last but not least, please take time. Like I told you, immediately after getting out of this session, don't forget my message. Please remember that in the chat window, right? If you exit, you may not be able to see the chat window. Go to the chat window and register for the meetup. First, create an Eventbrite account, register for this meetup, and also look for additional programs and register in all our social medias. And I know today there are a number of people who join newly. Thanks a lot for joining. And we are people-led grassroots movement, and I wanted you to nominate if you wanted to provide some training. You know, we all people help each other to grow. That's what Testoper is all about. And those who newly join, please go up in the chat and make sure that you join the WhatsApp group, provide your details so we can add you into the Microsoft Teams. You in Microsoft Teams is super critical, because you can collaborate with everyone before and after event. You can add value, posting the jobs, getting what other jobs are posted by other community members, applying for it. There's so many things that we can do together in this people-led grassroots movement. And I'm looking forward to you all to make sure that these 3 points you do it without any delay, right? Just take 5 minutes after you exit from this call or before you exit from this call. Do these 3 things for all as an appreciation for all the work that we volunteers are putting together for helping you guys to do. Thanks a lot for joining today. And I'm looking forward to you all joining other 2 sessions that are ongoing. One is on Wednesday, test automation, Tavern, Friday, Testoper project. You want to build something new, join that program, and also look for other programs, and please register everyone for the meetup. It's a super important that you join that meetup, because I'm pretty confident that you will learn a lot of good things in there. With that, let's close the session. Thanks a lot for joining. Take a time to do my request, and I'll be happy for today. Take care. Bye-bye.
Thank you, everybody, for the good comments.
Awesome.
Thanks a lot. Great session.
Thanks a lot.
Thank you.
Thank you.
Thank you.
Thank you.